in all the cord blood services. I will try to go to a talk where first we will try to fix the situation, the current situation of cord blood transplantation. And I think in this slide that you will see well from here, I would like to put together a little bit what we can call HLA paradigm that we gone along all the talks that we important for marrow transplantation. In principle, the message is that a better match has better outcome. Just recently, Mary has published in Blood the outcome of cord blood transplantation when considering an allelic match. Classically, cord blood transplantation has been performed just typing in low resolution for class 1 and in high resolution for DN1. But as you can see, one of the advantages of cord blood is that when you do an allelic typing, in spite that still the HLA full match in cord blood transplantation returns a better outcome in disease overall survival, the concept of permissive mismatch that we have been managing in all our talks may apply completely in cord blood transplantation, and we may take this as a concept that cord blood transplantation is, by definition, a kind of source with a permissive mismatch, because you can go down till, in this case, 4 out of 8 allelic match without losing patients. These are acute leukemias, obviously this doesn't apply exactly to every kind of disease. But on the right, you can see that this is not what happens with adult donors, where every single mismatch returns a 10% loss of survival. So taking this into account, we can bring to the audience the most important contribution of cord blood transplantation. If we are looking for a perfect match, and this is what we will end with a percentage of 25-30% of the patients having a donor. So we need to go to a kind of permissive mismatch that, as previous talks said, a 7 out of 8 is considered, or a 1 mismatch in adult is considered permissive mismatch acceptable. But we can go to up to 4 mismatch for cord. So in the area of the field of permissive mismatch, without entering in detail with HLA match we're talking about, there are 3 competing resources. The unrelated donor with a single mismatch, the cord blood, and currently they are identical with the cyclophosphamide post-conditioning. Here I have tried to summarize the benefits and the pros and cons of each of these alternative donor transplantation. And what looks most important for the audience is that cord blood is, as an advantage, a single source that has no donor concerns. We are recruiting the product after delivery without any risk for the donors, and this is the single, and probably one of the more important advantages for future consideration. But also the naivety of the stem cells and the T cells allows this transplantation having with a reasonably low incidence of GBC, acute and chronic GBC. So, my hypothesis is that cord blood is the best source of progenitor. That's true. I'm here invited to talk in cord blood, and I'm a cord blood banker. And the reason is that it is the universal solution for the unmet needs, and we will extend a little bit on that. Second is, again, the single source that guarantee a donor safety in the nation. Third, we can make in cord blood banks and approach the concept of off-the-shelf therapy. So having a product in a container that can be readily used for a patient without any delays in searching or testing the product. And this is something that we need to achieve in the future with the Querol line. Fourth, I think, is an already evidence-based medicine. This has been published already outcomes of 30,000 cardiac transplantation. This is not the case, for instance, for the academic surgery. And I think also we can say that we can make affordable inventories for the long-term coverage of all any groups worldwide. I mean, this is important because in Querol, we can maintain the donor product in a time that we don't need to renew the panel or the inventories of donors as occurs in a good donation. I want just to go briefly with four areas of improvement in coronal transplantation that I think is relevant. One is that we can improve and are improving the results just learning clinically things like, for instance, improving conditioning. So ATG-free conditioning has resulted in a better improvement of immune reconstitution. As you know, the infection is the main cause of death in coronal transplantation. Second, the GBL effect mediated by coronal is also demonstrated, and is, I will show some papers demonstrating through both coronal and maternal lymphocyte contained in the graft. Third, the long-term immune tolerance may result in a better quality of life in the patient. And fourth, the role of T-cell population in the graft and the outcomes. Recently, the French group in a model of tuberculosis transplantation shown that the immune reconstitution measured as infection burden, cumulative infection burden is not superimposable to that obtained with a 9 out of 10 bone marrow and transplantation. This is an ATG-free conditioning and has allowed the T-cell contained in the cord blood to participate in the early immune reconstitution of the patient. Second is the data for Seattle, and this mass score analysis published in 2009 in acute leukemia, they show that coronal transplantation is the source that results in lower taxes of relapse. And this was a surprise that there are new evidence that coronal is a very good source to treat high-risk acute leukemia. In this data from the Japanese group, they published a 7 years incidence of relapse of 4 patients with melanoma not in remission of only 30% with 61% survival. Third, and this is the first paper on quality of life, this is from a Chinese group, where they compare in the long term 186 consecutive treated patients. And if we go to the last paragraph, the long-term survival returning to school and work and off immunosuppressive therapy were significantly higher when using coronal transplantation compared to adult bone marrow transplantation in adult patients. So, and the last, and I think this is matter for research and the people that we are working in the coronal field, we want to explore better the T-cell component of our graft to improve survival. In the Karolinska group, we're the first to show that the content of certain subpopulation of lymphocytes in the graft has a very big impact in outcome, and particularly in Spain, the Valencia group that has recently published in Biology of Bone Marrow Transplantation that in a setting where you infuse sufficient number of cells in CD34, the overall content of CD8 of the cord result and predict a better outcome. So we are still learning in cord things that are a part of HLA, that are in the biology of the product, that may help us having a better outcome with this transplantation. So fixing a little bit the situation in cord transplantation, I just present this paper where the CADMTR and NMDP presented an algorithm for search where the recommendation simply is that when you don't find a completely matched donor, or the ability to find is very low in probability, you need to think both strategies, looking at less match as donor at the same time that you are looking for a correlate here. So, if HLA matters, I think the register strategy needs to look finding both areas, both registers, enlarging register, sustaining the capacity, increasing the efficiency, but also establishing and maintaining an operational number of units available. Just data from the Anthony Nolan in the importance of increasing efficiency of the register. You can see how in the last 3 years has just changing strategies of search, of recruitment and with donors. The number of days for providing CTs has decreased substantially, and also strategies like typing better, what we can call feed panels, meaning male young donors with frequent HLA haplotypes, might result in taxes of donors of donations up to 0.42% of those types. This is a borrow from Calvin's Miller, just to introduce that obviously adult and related registers need to be supported, but the challenge is how a register can recruit up to millions of donors. We did a study where, and actually, even, and this is data from NMDP, if you go to 8 out of 8 to 7 out of 8 on the right hand, you increase substantially the match level, but you cannot equalize the probability of access between ethnic groups. So a way to circumvent the problem of HLA match is to go to a 7 out of 8, but without achieving a complete even access to a match. We published that paper in projection of number of donors required for having potential good match in a carbon bank, and come with this discussion. I mean, a carbon bank needs to be fixed to a size because it's expensive, and we cannot afford growing unnecessarily. And I think this is a principle that anybody that wants to run a carbon needs to have. I mean, above 50,000 units, even with an optimal match, in this case 5 out of 6, the gain of new matches is very, very negligible. So the first thing to take into account is that the size of a carbon needs to be fixed in a very reasonable number, and according the capacity, the needs for a new population. The first paper publishing data on the impact of allelic matching in carbon was by Gregorian group. They compared the classical 4 out of 6 antigenic and allelic label with an allelic label in ABDRB1, and they come with this data that suggests that if carbon need to be transplanted according to allelic match, we need to enlarge approximately 50% the previously recommended inventories. So, concluding this part, the combining approach achieve, meaning adult unrelated and then correlate, if we don't find an adult unrelated, can achieve a reasonable access to a donor, but to all ethnic or major ethnic groups. Here there are 21 ethnic groups in the United States showing that between 80 to 95% of patients can find a donor with this combined expression. I will skip that. So, what is the matter that we need to do in the cord bank to meet the clinical needs? Basically, here what is important is to stress in the concept of quality. One of the major differences between a cord donor and an adult donor is that the cord is a product that is manufactured, that is elaborated in a laboratory. And we can, during this process, induce some changes in quality and viability of the cells that compromise later the engraftment. So, and I think for that reason, it's very important to define the cord inventory based in quality. This is the evolution of what we call an operational inventory. In the worldwide registry, there are 600,000 cords, but they are distributed, as we showed as you see in this table, with different grades of quality. The majority of the units belong has or contain very low quantity of cells. And if you can see here the difference in the inventory between 2010 and up to 2012, and the transplant rates per each category. So we recommend that a cord inventory should contain units above 150 per 10 at 7 gram cells to guarantee a probability of 1% transplantation of that inventory. And then I think this is important in order to maximize the cost and the benefit of your project. The other thing that the cord we are trying to review is the concept of the shelf. Nobody is taking time between the time between identification of a cord donor and the actual transplant, because many cord banks need to do extended typing, need to do quality controls, need to verify cells, and all this takes time. What is advisable is to concentrate in the good inventory in this unit what we can call a pre-release status in order that we can achieve this off-the-shelf concept. And what we are doing is to upgrade the units that are already in the tanks to do a higher typing. Second is to do upfront testing that are necessary for release, and focus in renewing the numbers that are in the tanks with very high cell numbers of cord units. In 5 minutes I will go a little bit fast, just in order that you see a technical operation of a cord bank. I can take the model of Barcelona just in order that you identify the critical part of a cord bank process. The first thing to say is that there is international standards that discussed by professionals, different sectors, and that are the FACT network standards. I think this is a good thing because we have a model that is a worldwide model to follow and that define what is a cord bank and define what is the minimum level of quality that you need to have. And I think what is advisable is that if you want to run a cord bank, you need to concentrate in how to do according to these standards. Obviously, the program starts with the educational part on maternity. Here we deal with mothers to be, in difference to other modalities of donation. You need to have a program linked with a collection center, usually a maternity. Impact of also you need to put in place conditions to maximize viability of cells, because it's complicated in a cord bank to collect and process very fast. Sometimes the maternities are far away from the cord bank, so it's necessary to validate methods of transportation and temperature monitoring. This publication that we did in transfusion will show that above 24 hours from collection to store, it's better to put the samples in a refrigerator environment. Also, it's important C34. I think data from New York Blood Center recently for memorial, and also this is a Spanish experience. CD34 in the cord graft matters. And this means that it's important also not to process units with high number of cells, but also with a non-CD34 content. This is our strategy of processing. We receive the cardboard units, we do the inspection, we do a triage based in weight, but then we do a bold approach to select the units that we will process, based in cell dose and biasing CD34 content. And we want to ensure that any cells that we process are above 4 million CD34 and 1.4 per 10 at 9 per cell. We have developed professional systems of monitoring the processing and the labeling. We do the reception and the acquisition. We do a volume reduction. We have implemented the labeling using the HVT 1-2A system that is what recommended standards. The automatic volume reduction make the products more reproducible in them, making the quality of your bank more robust. There are a second transformation, that is the cryopreservation. So we put the label in the bags and add the DMSO using coolers and sealing pumps that automatically add the cryoprotectant and heat track through the systems. And finally, we use long-term storage containers that can test or assess the individual thermal history. That is very important in corporate banking because you intend to collect units to be there for many, many years. If not, obviously, the cost-benefit approach of a core bank is not achieved. The cryopreservation is also tested. And finally, you have a product with a prescription information that could be available immediately. And you can use that information for selection. It's important also to have a fast-track realism test. We use segments for doing all safety, identity, potency, and viability with very small quantity of product, 100 microliters. You can validate the correlation between the segment and the bag, and in these conditions are good. And also develop functional flow cytometry to have potency tests performed immediately without waiting for CFUs. This apoptosis analysis shows you the viability of CD34 practically as a realism test in the same day that you can prepare the sample for shipping. And also it's important to establish the way you do the thawing. We have developing automatic methods for thawing the cardboard units in order to also make all the system very much controlled, because it is essential for guaranteeing the outcome of the transplantation. So, in conclusion, quality rather than quantity again and to help the clinical teams for having better success. So, just as a conclusion, I think what cardboard can allow us, and again, networking between different countries and registries, we don't need to fix a cardboard bank to cover all the needs that you have for a particular country, because you need then to develop cardboard banks of 50,000 units in each country. I think it's a nice model of networking, because if we do an international bank of high-quality units with 10,000 at least units for each major group, ethnic group, we can allow a source that can benefit practically almost all patients of any disease. So if you need anything or you have any question, I'm happy to answer later, or if you want to share your experience in corporate banking, I will be obviously here the rest of the